Okay, here's number trick 2. Again, we've written the steps vertically down the column here. We're just going to first do a quick run through with the set of numbers, and then we're going to draw the models. We're going to find that the models this time get kind of tedious, so then we're going to translate to symbols and appreciate the efficiency of the algebraic symbols. So suppose I started with 6 here. Then following the steps, I would go to 8 multiplied by 10, I'd have 80. Subtract 5, I'd have 75. Divide by 5 is 15. Subtract 3 is 12. Divide by my start number gives me 2. So my result is 2. Okay, what happens when I draw the models this time? Well, it starts out pretty simple. Here's my unknown quantity. I add 2, so as before. Now when I multiply by 10, oh, that's kind of tedious, but let's draw it out. I'm going to just kind of put them all together like this. 1, 2, 3, 4, 5. Just to make it go a little faster. Another group of 5. 1, 2, 3, 4, 5. So there's 10 copies of my original number, and then I need 10 copies of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 copies of the extra 2 dots there. Subtracting 5, well, that's going to amount to subtracting one of those columns. So let's 1, 2, 3, 4, 5. I still have all of the copies of my starting number. 1, 2, 3, 4, 5. But now I only have 3 of these columns of 5 of the extra amount. Okay, then I divide by 5. Okay, well that's less tedious. That's just one of these rows. So now I just have 2 copies of my starting number and 3 extra. Then I subtract those 3. Okay, so now I just have 2 copies of my start number. And in the next step, I divide by my start numbers. So that's a little bit more abstract here. If you think about really what it's asking is how many copies of my start number do I have? So I have 2 copies, and that's always going to be the result of that step. Okay, so that's how the models would look. Now let's translate to the algebraic symbols. Again, I'll start with x for my starting number. X plus 2 when I multiply by 10. Again, using 2 steps to see how the distributive property is visually motivated here. Subtract 5, so 10x plus 20 minus 5. If I were talking about like terms here, I could comment on the fact that subtracting 5 is only going to change the 20. It doesn't do anything to that 10x term. Then I divide by 5, and as before, I can see that it's important that I divide both terms by 5. So that gives me this result. Then I subtract 3, leaving me just 2x. And now, when I write algebraically this step, 2x divided by x, I can see that the x's are going to cancel out, or I could divide by x on both the numerator and denominator, and I'm going to get 2. So we've shown how the algebraic steps show more efficiently the same generalization that the models showed here. Okay, so that's all for this video. What we're going to do in the next video is go back to the steps in number tricks 1 and 2 and show how we could write all of the steps in one large algebraic expression, and then how we could carefully simplify that one large expression.